Hey YouTube, fellow math students and math teachers, DeVore here again, and today we're going to be examining factoring quadratic functions. I felt that this needed a little extra, just because out of all of the different ways that we can find solutions of quadratics, this seems to be the one that my students struggle with the most, and I wanted to do a separate set of notes for these. Alright, first off, we're going to do a little bit of review here. Here's what we're working with here. Alright, this is a standard quadratic function written in factored form. The reason why we know that it's in factored form is because we have these two parentheses blocks. And what that's telling us is that we have x plus 2, and then we have times x plus 6 equals 0. And when we are finding the solutions of a quadratic function that is in factored form, really what we're looking for is if we look at our two blocks here, let's highlight these. We've got x plus 2 here in green, and then the x plus 6 here in yellow. Alright, what this really means for us, is that we have these two numbers multiplied together, and they equal 0. Well, if we think back to what we know about multiplication and 0, we know that in order for this to be true, this x plus 2, that number, must be equal to 0, or x plus 6 needs to be equal to 0. That x plus 2 block and that x plus 6 number block are just numbers. We just don't know what they are yet. It depends on what we put in for x. But they really are just two numbers multiplied together. Think of it that way. That's the reason why I did the color coding. Now, in order for us to figure out what values of x will make these two numbers 0, well, here we've essentially set it up ourselves. If I know that x plus 2 equals 0, this means that x must be negative 2. Alright, by that same token, if x plus 6 equals 0, by that same token, x equals negative 6. In the context of our quadratic functions, if you're thinking about this on a graphical sense, what this is saying is that if I were to put this, in my table of values and I found my parabola would cross the x-axis at negative 2 and negative 6, which is handy, and for many physics problems and economics problems, knowing these values is actually very important. For instance, in a physics problem, knowing where it crosses the x-axis will tell you how far away the football landed when you kicked it. That's actually probably a very common example if you were to look up applications of quadratic functions, say on Google or in a textbook. But these numbers are very important to us because it actually does tell us a lot about just the way that this parabola looks. Because if your x-intercepts are very close together, then it's a very skinny parabola. But if they're very far apart, then it must be a fat parabola, and there's things that go with that. Alright? But let's say that I didn't start with this. Let's FOIL it out. Humor me here. Let's FOIL this guy out. Remember that when we FOIL, we go first, outside, inside, last. In this case, we've got x squared plus 2x plus 6x plus 12 equals 0. And like the diligent algebra students that we are, we're going to combine our like terms. So the 2x and the 6x are going to combine to make 8x plus 12 equals 0. Let's say we started there. We didn't know that it condensed down into these lovely little parentheses blocks. What we want to do is we want to unfoil this guy. That is the point of factoring, is we are unfoiling a quadratic function so that we can bring it back into a form that's frankly a little easier to work with when we're finding these x-intercepts. I'm going to show you guys a method that my students really seem to like. And once they try it a few times, especially on a whiteboard, they actually, I think, really do like it. And it means that we're going to steal from biology for a second. Okay? We're going to rearrange the terms of this into what we call a Punnett square. So here's our Punnett square. I'm going to make this a little bigger. A little bit bigger. There we go. We have our Punnett square. And in biology, you use Punnett squares more to track gene distribution, looking at traits, things like that. Well, we're going to use it in a way that looks very much like biology, but it's now math, because we're in math. All right? We are going to rewrite parts of this equation that we now have in here. So we're going to start out with x squared, and I apologize, this will not let me make it pretty. We're just going to have to go with it. We write our first term, our x squared term, up here in the top left. We write our not variable term, our constant term, down here in the bottom right. Now, we need to fill these two squares, but we only have one number. That means we need to split it up, the unfoiling part, we need to split it up into our two numbers. And I mean, you could just say, well, DeVore, it's right up above here. We have it split into two parts already, yay! That won't always be the case. That will be written for you. So I'm going to show you how you find that by yourself. Okay. We're going to make a table. And on the top of our table, on this left-hand side, we're going to have what I'm going to call A times C. Well, what's A and what's C? We're going back to the standard form of our quadratic function here. A is the coefficient of our x squared term, which is just 1. And then we have our C term, it's this term right here at the end. So it's going to be times 12. Well, 1 times 12 is 12. That's our first number. Our second number is we look at our B term. In this case, it is positive 8. Now, we did all that work, but now let's figure out really what we're doing here. We are looking for a pair of numbers that multiply together to equal 12, but add together to equal 8. As an example, if I did 3 and 4, 3 times 4 is 12. But when you add them together, you get 7, which is decidedly not 8. Let's go with the obvious numbers, the numbers we know, as 2 and 6. 2 times 6 is 12, and miraculously, they add up to 8. Awful convenient. Now that we have these numbers, I'm going to go ahead and I'm going to just highlight that. Let's put them in the appropriate places in our table. Take our first number, we have 2x. And I find it helpful to put, sorry, technical difficulties. There we go. I find it nice to put the plus in front of it. It helps me to keep my sign straight. All right. We've essentially rewritten this line right here. We've essentially rewritten it in this box, just in a slightly different fashion. Now here's the part where we're going to be breaking this number apart. This is where the unfoiling truly happens. Okay? We are going to go square by square, and we are going to factor this in a very particular way. For instance, x squared comes from my first. That's my first thing from FOIL. It's first. Something times something equals x squared. Now, x squared is really just x times x. How I'm going to represent that is that I've got an x here, and an x here. There we go. All right. That, if I multiply the x and the x together, I get x squared. That's totally true. Now I'm going to take this x right here on the left-hand side, and I'm going to bring it over to my upper right square. And this is saying that I'm doing x times something equals plus 2x. Well, I'm just missing then a plus 2. And then I'm going to take the x from the top. I have an x, and I've got plus 6x, which means I am only missing plus 6. All right. You should see some very familiar numbers there written on the outside. If I want to write this now in factored form, my factored form looks like x plus 2, just the numbers from the top, and then the second parentheses I put x plus 6 equals 0, which, interestingly enough, is exactly where I started. So you can see then how we use that table to unfoil, as it were. Let's do one more example together where, first off, we don't know where we're going, and second off, it might be a little bit trickier. All right, let me get that down for you. Let's do the example of x squared plus 5x plus 6 equals 0. Now we don't know where we're going, but we can certainly find out, can't we? Let's make our little tables here. Here's our Punnett square. And let's give it a little more breathing room. There we go. And yeah, this will be fine. All right, we start out by writing x squared up here and plus 6 down here on the right. Now we need to make our AC table. Okay. Remember that my A term is out here. My A times my C gives me plus 6. And my B term is 5. Now, let's just go with the obvious. We've got 1 times 6, which adds up to 7. All right. 2 times 3 gives me 6, and that does add up to 5. Cool. Let's just go ahead and highlight that. This is what happens when I use a trackpad and not an actual mouse. All right. Let's put this in. We have 2 plus 2x plus 3x. Okay. Now this one, just by the very nature of the numbers that I picked, you can see across the top that we're missing an x and an x. If we go straight across, we get a plus 2 and a plus 3. Now you may be noticing a pattern in terms of the numbers that I get look very similar to the numbers that I got from the table. It's cute, don't rely on it. It's just a fun little party trick. Don't count on it. When we start getting into some more complicated examples, like the one I'm going to do next, you'll see why relying on the table like that's not a good idea. Okay, so x plus 2, x plus 3 equals 0, which means that x is negative 2 or x is negative 3. All right, I think that's a pretty good example. Let's do one more, and then I will wrap this video up. The example that I'm going to pick is 2x squared plus x minus 6 equals 0. All right, so this is now where we have a number for a that's not 1. And I'll show you how that works in regards to our Punnett square. It doesn't actually change much, as you'll see. The way that we've set this up, it'll actually work out very well for us. Okay. Here we've got our Punnett square. And we've got now 2x squared. Got minus 6 down in the corner. Okay, and now we have our table. We have a times c, which is 2 times negative 6, gives us negative 12. Our b term is 1. All right, now this is also the first time that we've had to deal with negative numbers in any capacity, but it's not really that tricky. You just have to keep in mind negative numbers. What kinds of things multiply together to make negative numbers? Remember that a negative times a positive gives you negative numbers. All right, so let's get the obvious ones out of the way. Let's say negative 2 times 6 will give us negative 12, but alas, adds up to 4. And we can try 2 and negative 6, which also works, but gives us negative 4. Let us try, let's see, 3 times 4 gives me positive 12. Let's do negative 3 times 4, which will give me negative 12. And lo and behold, negative 3 plus 4 does give me 1, which is exactly the number that I'm looking for. There we go, highlighted that. Let's put that where it belongs. We have negative 3x and positive 4x. We're going to start out the same way with making our Punnett square. We're still going to have an x and an x to start. And it's just a good placeholder for things like this because we know that each of those corners is going to have an x. We know that. But now we need to figure out where that 2 is going to go. And for that, we need to use a little bit of reasoning. When we factor, we want to get nice whole numbers. No fractions, no decimals. We want them to be nice, really. If I were to put a 2 here, over here on the left, well, when I'd go over here to my negative 3x, I'd have to figure out if negative 3 divided by 2 gives me anything nice, and it really doesn't. So I'm going to go ahead and just not do that. If I put the 2 up here, when I go to figure out what's missing from my 4x, I've got 2x, I need a 4x, which means I just multiply this guy by 2. And it comes out very nicely. A question that you essentially ask yourself is, if I were to divide 4 by 2, 4 divided by 2, would I get a fraction, yes or no? If the answer is yes, then you might want to look elsewhere. You might need to fiddle with the numbers a little bit, or frankly, put them in different spots. All right, back to this. So I've got my 2x taken care of. Let's take care of our x. We are missing a minus 3x right here. All right, let's go ahead and factor this properly. We get 2x minus 3 times x plus 2 equals 0. Which means that my x's, when you go and you do the math, you should get x is equal to 3/2 and x is equal to negative 2. And so in this way, you will get for some fractions, and fractions are okay. It's just the way that these end up working out. You're not always going to get them right on, and that's okay. All right, that has been my video on factoring quadratic equations. If you have any questions, please feel free to visit me during my office hours or send me a message, and I'll be more than happy to help you out. If you like what you see, please remember to like and subscribe and send me a message and let me know if there's any videos that you would like me to do that are not currently up on the channel. As always, please remember to have an awesome day, and yeah, bye.